My name is Roger, and this is Mr. Rogers' Math Corner, and I'm here to help you solve problems you will definitely see in your class. So today we're going to do systems of linear inequalities. Now, we've done systems of equations by graphing, and this is very similar. So if you want to see my video on systems of equations by graphing, I've posted the link here. So this is linear inequalities. And remember, with an inequality, there's an infinite number of answers. And with these, we have to find out where the infinite answers for the first equation and the infinite answers for the second equations meet. And that is the answer to our systems of linear inequalities. So let's look at what we have. We have y is greater than or equal to negative x plus 2, and y is greater than or equal to negative 4x minus 1. And you know something? I'm going to change this just a little. I'm going to take away the equal sign from here. So the second one is just going to be y is greater than. Okay, so when you're given these equations, remember, in order to graph them, they have to be in y equals mx plus b form, which is our slope-intercept form. Okay, so when we graph them, we're going to pretend that this is an equal sign for now. So my first equation, y equals negative x plus 2. 2 is my y-intercept. So I'm going to put a point at positive 2. That is my y-intercept. The slope is the number in front of the x. So in front of the x is just negative. So it's an invisible 1. So it is negative 1. So remember, so I go down 1 and over 1 and down 1 and over 1. So a negative 1 looks like this. Okay? And because this is greater than or equal to, this will be a solid line. That's why I changed the other one, because I wanted to show you the difference between a solid line and a dotted line. Okay, so I have graphed this line, but remember I said, well, when you're graphing, pretend it's an equal sign, but it's not. It's an inequality. This is y is greater than or equal to negative x plus 2. So in other words, there has to be shading on one side of the line or the other. Okay, the infinite values are either this way or that way. So how do I find out where they should be? Okay, so what you do is you pick any point on one side or the other of that line. The easiest one to use is 0, 0. So if you're not going through that 0, 0, use that point. Okay, so 0, 0, if I plug this in, my y is 0, my x is 0, and 0 plus 2 is 2. So now the question is 0 greater than 2? Well, the answer is no, 0 is not greater than 2. So that means the 0, 0 point and every point on that side of the line is no good. So that means the shading goes on the other side. So I shade the other side, all right? So this is kind of where some students stumble, all right? So let me just repeat it again. I've plugged in my 0, 0. So y is 0, my x is 0, and 0 plus 2 is 2. So now you look at the equation and it says 0 greater than or equal to 2. Well, that's false. 0 is not greater than or equal to 2. So therefore, that 0, 0 point and every point on that side is no good. So we shade the other side. If it was correct, I would shade that side. Okay, so now let's look at our second equation. So y greater than negative 4x minus 1. So my y-intercept is minus 1. So I'm going to put a point there. And my slope, negative 4. So that's a rise of negative 4, a run of 1. Remember, any whole number you can put over 1 to get your run, my rise over run. So this is down 4, 1, 2, 3, 4, and over 1. And if I can, I do another one, 1, 2, 3, 4, and over 1. Okay? Now, because this is, the inequality does not have an equal sign, that means this line has to be dotted. Okay? Not solid, dotted. All right? Okay. So, let's straighten this out. There we go. So as you can see, the dotted line does not go through 0, 0. So I can use 0, 0 as a testing point. Okay? I need to know which side of the line that I am highlighting, that I am going to shade. All right? So 0, 0. So y is 0. Negative 4 times 0 is 0. and 0 minus 1 is negative 1. Is 0 greater than negative 1? In this case, yes, 0 is greater than negative 1. So I am going to highlight the 0, 0, and every point on that side. So that means I'm highlighting this way. And you look and you say, okay, where are they both highlighted? Well, they're both highlighted over here. So this is the solution. I put a big S there, and that is the solution to this linear inequality. Now, sometimes on exams, they will give a point in the dotted line, okay? Let's pretend they're doing this point over here. I'm going to circle it. And they'll ask, is this in the solution? Because it's on the dotted line, it is not part of the solution, okay? If it was on the solid line, it would be. See this point here? I'm going to circle this one. That is in the solution. But on the dotted line is not on the solution, because the dotted line says, don't include me, but include everything on this side, all right? All right, so that is how you do a systems of linear inequalities. If you're given equations where you don't have it in y equals mx plus b form, you must do your algebraic manipulation, all right, so that you have y on one side and everything else on the other side, and then you graph from there. That is our solution. And now it's time for the joke of the day. What was the butterfly's favorite subject? Mathematics. My name is Roger. This has been Mr. Rogers' Math Corner, and I'll see you next time.